Hello, this is Maria from Math Mammoth, and this is Mathy, my mascot. In this lesson, we are studying how to use scientific notation in calculations. And here's my first example. How many times bigger is 6 times 10 to the 5th than 3 times 10 to the power negative 4? Here we are looking at a multiplicative comparison. How many times bigger, or how many times the smaller number equals the bigger number. We are not looking at the difference between the numbers, such as how much bigger is 80 than 20. You might think of it as 80 minus 20, but no, we are thinking of as 80 is 4 times bigger than 20. Okay, so with these numbers, since we're looking at the multiplicative comparison, we're going to divide the bigger number by the smaller to find the answer. The bigger number is 6 times 10 to the 5th, and we divide it by 3 times 10 to the power negative 4. And here, 6 divided by 3 becomes 2, and then this divided by that. We get a 10 to the power of what? We can subtract the exponents here. 5 minus 4. 5 minus 4. Okay? And we get 2 times 10 to the 9th. So the bigger number is 2 billion times the smaller number. Alright, let's look at another example. We have mass of the Earth as 5.9722 times 10 to the power of 24 kilograms. So the Earth is pretty massive. Huh? Matt is saying that he's also massive. That's true. You are massive, but not nearly as massive as our Earth, okay? Mass of Alice, 58.1 kilograms, and then mass of an ant, 2.5 times 10 to the power of negative 3 grams. Not kilograms, but grams. If we compare Earth versus Alice, then we will take the bigger number divided by the smaller, and I have written it out. The Earth's mass divided by Alice's mass. Now, if we divide, we can put this portion here into the calculator, and we will get this. It's about 5.97 divided by 58.1, so it's close to 1/10 here. And then we have the kilograms, which will cancel out, and we're left with this 10 to the power of 24. The only thing that's left now is to write this in proper scientific notation, not as 0.1, but as a number that is between 1 and 10, and then to round the answer according to the rules of the significant digits. So let's do that. First of all, if we do the rounding first, then we look at how many significant digits we had here. Okay? The least number of significant digits is the 58.1, and it has 3 significant digits. So here also we need to take 3 significant digits and round it like that. 0.103 times 10 to the power of 24, and then to proper scientific notation, which means this becomes 1.03. And how does the exponent change? Since this has to become 10 times bigger, then this has to become 10 times less than it is now. It loses 1 of the 10 times, so to speak. So the Earth is about 1.03 times 10 to the 23rd times the mass of Alice. Pretty massive. Now, if we look at then Alice versus the ant, Alice is heavier or more massive, so her weight will go on top, and we will divide the two. 58.1 kilograms divided by 2.5 times 10 to the power of negative 3 grams. Okay, but we have here kilograms and grams. So to do the proper comparison, we have to have the same unit, so we can cancel it out. So our first task here is to either convert the kilograms to grams or the grams to kilograms. I'm doing the former. 58 kilograms is easy. That would be 58,000 grams. And so this becomes 58,100 grams. Okay, now the grams will cancel. And then we will use a calculator. And from a calculator we get 23,240. And then we still have this, well, it becomes 1 over 10 to the negative third. And there's no grams or kilograms anymore. This is just a plain number. Now, this here, we could write it in scientific notation to 0.324 times 10 to the power of something, because that way we can use scientific notation in calculations here. These powers of 10 will be very easy to handle. This becomes 10 to the fourth. And now 10 to the fourth and 10 to the power of negative 3, we can use the exponent law where we subtract the exponents and get 10 to the seventh. And now check the rounding. How many significant digits did we have? Over here, Alice's mass had 3. The other one had 2. So we'll need to round this to 2 significant digits, only 2.3 times 10 to the seventh. So that is how many times more massive Alice is than one ant. It's a big number. Okay, and that's all. I hope it was helpful.